Good morning, dear student. Today I am going to discuss about the work done by an ideal gas in isothermal expansion. And already I had discussed in the previous video the isothermal and adiabatic process, isothermal and adiabatic curve, and now I am going to discuss about the work done by an ideal gas in isothermal expansion. Actually, in isothermal expansion, in the case of ideal gas, in isothermal expansion, the work is done by the gas. And suppose if the initial pressure of the gas is P, and when the volume of this gas P increases by a small amount dV, then in this process, the work done dW is equal to P into D, which already I had discussed in the previous video here. Suppose instantaneous pressure of a gas is P, and when its volume increases through a small amount dV, then in this process the work done by the gas dW is given by P into dV. So here, work done by an ideal gas in isothermal expansion. Suppose mu mole of an ideal gas, हमने किसी आइडियल गैस का म्यू मोल लिया, तो सपोज म्यू मोल ऑफ एन आइडियल गैस एट एब्सोल्यूट टेम्परेचर T be expanded from initial volume V1 to final volume. हम इनिशियल वॉल्यूम V1 से फाइनल वॉल्यूम V2 तक उस गैस को क्या किए, एक्सपेंड किए. Then our aim is to find what the work done in this process or what is work done under this isothermal expansion. The mu mole of an ideal gas at absolute temperature T, when its volume increases from V1 to V2, then the total work done is how much? So for a small work done dW is P into dV. So in this process, the total work done we can find by integrating this one. Integrating both sides. So you can say dW is equal to P into dV. So when we integrate it both sides within limit V1 to V2, you can say integration of dW is W is equal to here V1 to V2, and this one is P into D. So this one is the total work done to increase the volume of this gas from V1 to V2 at constant absolute temperature T for how many mole? For mu mole of the gas. And you know, isothermal process obeys the Boyle's law. Since isothermal process obeys Boyle's law, and you know Boyle's law, PV is equal to constant, or you can say P1 V1 is equal to P2 V2. But from ideal gas equation, for ideal gas equation for mu mole, you know PV is equal to mu RT. For mu mole of an ideal gas, its equation is PV is equal to mu RT. So from here, P is equal to mu RT upon V. This one, ये मैंने आइडियल गैस इक्वेशन लिखा है म्यू मोल के लिए कि PV is equal to mu RT, तो P is equal to mu RT upon V. Now at place of P, अब यहाँ पे हम इस P की जगह पे mu RT upon V लिख सकते हैं. So here W is equal to V1 to V2 at place of P mu RT upon V, mu RT upon V into here this one is P. ये mu mole, number of moles, are gas constant. What is T here? T is the temperature, absolute temperature T, and since this process is isothermal process, so here T is constant. So here mu for a given gas, number of moles mu is constant, R is a gas constant already, T temperature in isothermal process T is also constant, it means mu RT is constant. So we will take all these three terms mu RT outside. So W is equal to mu RT, and here V1 to V2 we can write as 1 upon V in this. And you know there is a formula for integration. Here note that integration of 1 upon x dx. This one is equal to log x to the base. This is the formula of integration of 1 upon x dx is equal to log x to the base e. Similarly, integration of 1 upon v dv, we can obtain is equal to w is equal to mu rt, and here 1 upon v dv, like 1 upon x dx log x to the base e. So 1 upon v dv is equal to log v to the base e, and here v1 to this. Integration of 1 upon v dv, like this one, 1 upon x dx log x to the base e. Similarly, 1 upon v dv is log v to the base e, and here limit v1 to. Now we can see here, if w is equal to mu rt, and here first at base of v, we will write upper limit, minus again at base of v we will write lower limit. So you can write log v to the base e minus log v1 to the base. And I hope we all of you know this formula. Log a minus log b is equal to log a upon b. So here we can write w is equal to mu rt log v2 upon v1, and hold this. So this is the formula for work done by an ideal gas in isothermal expansion. What? W is equal to mu rt log v2 upon v1 to the base e. But you know, isothermal process obeys Boyle's law, and according to Boyle's law, P1 V1 is equal to P2 V2. So from here, V2 upon V1 is equal to P1 upon P2. So same relation also you can write in terms of the pressure of W is equal to mu rt, and here log at base of v2 by v1 you can write p1 by p2. So here p1 by p2, So in this way you can say the work done by an ideal gas in isothermal expansion is given by simply W is equal to mu rt log v2 by v1 to the base e, or W is equal to mu rt log p1 by p2 to the base e. And finally you can say what done W is equal to mu rt log v2 by v1 to the base e, or this is equal to mu rt log p1 by p2 to the base. And when we change base e to base 10, यहाँ पे base e है, हम इसको जब base 10 में चेंज करेंगे, then here we multiply by 2.303. So W is equal to 2.303 mu rt log v2 by v1 to the base 10. Or you can say this is equal to also, or W is equal to 2.303 mu rt log, here in terms of this one, p1 upon p2 to the base 10. So यहाँ पे बेस e है, और बेस e को बेस 10 में चेंज करने के लिए हम इसे मल्टीप्लाई कर देंगे 2.303. So in this way you can say work done by an ideal gas in isothermal expansion is given by W is equal to 2.303 mu rt log v2 by v1 to the base 10, or W is equal to 2.303 mu rt log p1 by v2 to the base 10. And remember this, if v2 is greater than v1, अगर v2 v1 से ज्यादा है, इसका मतलब अगर एक्सपेंशन हो रहा है, फाइनल वॉल्यूम इज ग्रेटर देन इनिशियल वॉल्यूम, तो when v2 is greater than v1 or when v2 upon v1 is greater than 1, the work done be always positive और work done positive का मतलब क्या हो गया work done by the gas इसका मतलब यहाँ expansion हो रहा है but suppose if the compression take place so in the case of the compression when V2 is less than V1 and when V2 is less than V1 then V2 by V1 or the log of V2 by V1 will comes negative means this work done will comes negative and negative work done means work is done on the gas. So two possibilities by the gas or on the gas. When expansion will take place, then V2 is more than V1. And when compression will take place, then V2 is less than V1. And remember this, when V2 greater than V1, work done by the gas, and when V2 is less than V1, when final volume is less than initial volume, then work is done on the gas.